Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the introduction to definite and indefinite integrals. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, assuming we have the function y, okay, and we are able to convert this function to what? Dy dx. Okay, we call this what? Differentiation. That is what? We differentiate the function with respect to what? With respect to what? X. Now, what happens if you want to go the reverse way? That is, we want to convert dy dx, okay, to what? The function y. We call this what? Integration. So simply put, integration is the reverse of what? Differentiation. Alright. Now there is a general way of what? Integrating a function. So assuming we have the function of the form ax power n, how do we integrate this function? Now we integrate the function by applying the sign big S to the function. Then we add what? The s to it. Okay, so what this means is that this sign, okay, means the integral of, okay, then the s means what? With respect to s. So it means we are integrating what we have over here with respect to s. Now, like I said, this is our integral sign, and then the function over here, okay, becomes what we call the integrand. The integrand. Okay, now this is what? With respect to what? X. Okay, so with respect to what? X, or any value or any variable that we have over here. Okay, and then this is our what? Our integral sign or symbol. Okay, so now if we integrate the function that looks like this, let's look at the general form. Okay, now if we integrate the function, all we do is what? We add 1 to the power or the exponent or the index of that function, and then we divide it by the new what? Power. So what I mean by this is, if we integrate this function, we are going to get what? Ax power n plus 1, all divided by what? N plus 1. Then we now add a constant to it. So it means to differentiate the function, all we need to do is what? Add 1 to the power and then divide that by what? The new power that we have over here, which is what is over here. Okay, now the c is called the constant of integration, or the arbitrary constant of what? Integration. Now the process of integration, where the constant of integration is not known, is what we call the indefinite integral. Okay, so this form of what? Integration, where we don't have any limit to the integration. So after we integrate, we need to add c, which is a constant, and we do not know the value of the constant. We call this what? Indefinite integration or indefinite integral. Indefinite integral. Now let's have a look at an example of how to easily integrate. So if we have the function, we have to integrate what? 2x power 4 dx. Okay, so this is an example of what? An indefinite integral, and all we do is what? We say this is equal to, so to integrate this function, it means we add 1 to the power and then we divide it by what? The new power that we now have. So it will become what? 2x power 4 plus 1, all on what? 4 plus 1. Then we add a constant c, because it is what? An indefinite integral. So this becomes what? 2x power 5, all on 5 plus c as our answer, or if you like, you can bring it out 2 over 5 x power 5 plus c as the answer for our integration. Now let's have a look at another simple example. So we have to integrate root x with respect to what? X. Okay, so to integrate this, root x can be rewritten as what? X raised to the power half dx. Okay, so from here all we need to do is what? Add 1 to the power. Okay, and then we divide by what? The new power, and we add what? C to it. Now if we add 1 to half, that becomes what? 3 over 2. So we have x raised to the power 3 over 2 on what? 3 on 2 plus what? C. Okay, so if we rewrite all of this, we are going to get what? We bring this to the top, it becomes what? 2 over 3 multiplied by what? X raised to the power what? 3 on 2 plus what? Plus C as our answer. Now how do we integrate a constant? Okay, so integrating a constant. Okay, so assuming we have a constant, let's say integral of k, and k is our constant, and we are integrating it with respect to what? To x. All we do is what? We add x to the constant. So if we integrate a constant, it becomes what? Kx, then we add c to it. Okay, so for instance, if we are to integrate 7 dx, okay, 7 dx, if we integrate it, it becomes what? 7x plus c. The same way, if we are to integrate, let's say 9 dx, okay, because 9 is just a constant, if we integrate it, it becomes what? 9x, then we add what? C to it. Alright, now let's look at how we integrate a sum or difference of a function. So assuming we have the function of the form, the integral of what? A sum of functions, let's say sum and the difference of functions. So we have the function f of x plus another function g of s, then minus another function h of what? X. And we are what? Integrating with respect to what? With respect to x. How do we solve this? So this is what? We integrate each of the individual functions within this curly bracket individually, and we add all of them, and that becomes what? Our integral, or our integration of the entire function. So this becomes the integral of what? The function f of x with respect to x, plus then we apply the integration to the second function, which is what? Integral of what? G of x dx, then minus the sign over here is still here, integral of what? H of x dx. Okay, so this becomes our final integration for this particular example. Alright, so with this, let's have a look at an example. Alright, so the first example we want to look at is we are to integrate the function 3x plus 2s squared minus 5 dx. We can see that this is of the form this that I've given over here. So let's go ahead and look at what? How to integrate this. So this will be equal to the integral of the function 3x dx plus the integral of what? 2s squared dx, okay, minus the integral of what? 5 ds. Now the 3 over here is a constant, so we can bring it outside of the integral sign. So we have 3 integral of what? X what? Dx, plus we have 2 over here, so we can bring it out, 2 integral of what? S squared dx, then minus, this is just the normal constant, so we maintain it, to integral of what? 5 dx. Okay, so we have over here 3. Now if we integrate s, it means it has power of 1, so we add 1 to that power, and we divide all by what? The new power is 1 plus 1, then plus, this is 2 already here. If we integrate s squared, we add 1 to the power, and then we divide by what? The new power, then minus, we have what? Just a constant over here, so we add x to it. Okay, so it means we've differentiated everything we have over here, to become this, so we add c to it. So it means our final answer after this will be what? 3 on 2 multiplied by what? S squared, plus we have 2 on 3 s cubed minus what? 5s plus c as our answer for this particular example. Now let's look at another example. Let me use another color for that illustration. So the second example we want to look at, example number 2, is if we are to integrate the function m cubed plus what? 3m squared minus 1 all over what? M squared, then dm. Okay, so it means we are integrating m with respect to what? M. Okay, so this becomes what? Before we integrate, we need to simplify what we have in the bracket. So we have the integral of what? This becomes m cubed on what? M squared plus this variable over here, 3m squared over what? M squared, then minus 1 over what? M squared dm. So this will cancel some of this, so we still have integral of what? This will become m plus here will become 3 because this cancels this. Okay, then we have plus, minus, this is what? 1 over m squared. So if you bring m to the top, it becomes m raised to the power negative 2 dm. Okay, so from here we can integrate each of the variables separately. Now I can express this in the form this by applying the integration to each of them individually, and then I integrate, but that will waste time. But in case of exam, you need to do that for the teacher or the lecturer to see. But I'm going to be skipping this step and then jump all the way to this step at once. So it means from here, if I integrate m, I know I'm going to have what? Our m, it has power of 1. I add 1 to it, then I divide by what? The new power, which is 1 plus 1, then plus, this is a constant. I know if I integrate a constant, I add what? S to it, but in this case I'm using m, not s, so I add what? M to it, so it becomes what? 3m, then minus, I now have this m, this is the power negative 2, so it means I need to add 1 to the power and divide by what? The new power is negative 2 plus 1, then I add a constant c. So from here I can go ahead and have what? This is what? M squared over what? 2 plus what? 3m, then minus, this becomes m raised to the power negative 1 all divided by what? Negative 1, then plus c. So it means my final answer will be m squared over 2 is still 1 over 2m squared, then plus 3m. Then the negative here will cancel the negative here, so it becomes positive. So m inverse is just 1 raised to the power 1 divided by m, then plus c. So this is our answer after we integrate the function this. Okay, right. So now let's move to what? Definite integrals. Now, like I said, if you have a function of the form ax power n dx, okay, if we integrate this, it means we have ax power n plus 1 on what? N plus 1, then we add c, because what? There are no limits to this what? Integration, and this becomes what? Our indefinite integral. But now, what happens if we know the limit? That is, what happens if we say let's integrate from point A to point B? That is, if we want to integrate from, let's say, 3 to 1. Sorry, if we want to integrate from 1 to 3 of the function ax power n dx. So it means if we apply, these are what we call the limits. Okay, so it's limiting where we are to integrate from and where we are to stop. So we are integrating from 1 to what? 3. Okay, so it means all we need to do is what? If we integrate the function, we are going to have ax power n plus 1 on what? N plus 1. Then we now apply the limit to this. So we have 3, 1. So it means we need to express this in the form, wherever we see x, we put what 3 over there. So it means we are going to have something like this: a into brackets 3 raised to the power n plus 1 all over what n plus 1. That is for the first one. Then minus, we subtract the lower one from it, so that will be what a raised to the power 1 n plus 1 all over what n plus 1. Sorry, not a raised to the power. It is what a multiplied by what 1 raised to the power n plus 1 all over what n plus 1. So this is the format it goes. That is, we have a limit to the integral that we now have. That is, we are integrating from 1 to 3. And so after we do the integration, we apply the limits to it, and that is, we substitute the 3 over here, or the value at the top over here, in place of x. Then we do that calculation and we get the answer. That is what we have over here. Then we substitute 1 over there, we get that as well. So we subtract the lower one, the one at the bottom over here, from the one at the upper one over here, and that will give us what our answer for our definite integral. Alright, so with this in mind, let's have a look at an example. So let's look at this example. So we are to integrate from 3 to 1 the function 3x squared plus 2x plus 4 dx. Alright, so let's look at how we solve this problem. So we are to integrate from 3 to 1 the function 3x squared plus 2x plus 4 dx. Okay, so it means we are to integrate each of these functions individually. Now I need to apply the integration throughout all of them, and I solve, but I'm going to skip that step as usual. So I'm going to have, I know if I integrate 3x squared, I'm going to get 3x squared plus 1. Then I divide the power, I divide it by what? The new power, which is 2 plus 1. Then plus, I have 2x, so I know it to be 2x, 1 plus 1. That is, it already has a power of 1. I add 1 to it. Then I divide that by what? The new power, which is 1 plus 1. Then plus, if I integrate a constant, I know a constant, I need to add what? X to it, so it becomes what? 4x. Then I apply my limits 3 and 1 to this. So this is equal to, I have here 3x power 3 divided by 3 plus what? 2x squared divided by 2 plus what? 4x. Still applying what? The limits 3 and 1. So this will cancel this cancels this. It means my final equation is what? S cubed plus what? S squared plus 4x with the limit what? 3 and 1. So this becomes what? First of all, I substitute my 3 over here, so it becomes 3 cubed plus what? 3 squared plus 4 into brackets 3. Then minus, I now substitute 1 in place of x. So I have 1 cubed plus what? 1 squared plus 4 into bracket 1. Okay, so if I do that, I'm going to get 48 over here. Then minus, over here I'm going to get 6. So it means my final answer becomes what? 42. So if we integrate this function, the answer we get is what? 42. And this is an example of what? A definite integral, or this is how a definite integral looks like. Alright, so let's have a look at another example of a definite integral. So we have to integrate from negative 2 to 2 of the function s squared minus 2 and then 2x minus 1 dx. Alright, let's write down our solution. Now, if we look at this, we can see that we have two functions multiplying each other and we have to integrate it. Okay, so the first thing we need to do is to expand our function so that we have it in a linear form, so that you can be able to what? Apply our integration to each of the functions individually and then find our final integral. So it means this will be what? Integration from -2 to 2. Then I use s squared to multiply everything, so I'm going to have s squared multiplied by what? 2x minus 1. Then minus the -2 over here is over here. Then 2x minus 1. Okay, or what? Dx. So it is what? The integral from -2 to 2. Now if I use the s squared to multiply this, I'm going to get what? 2s cubed. Then minus this will give me s squared. Then minus this will give me what? 4x. Then this will give me plus what? 2. Okay, dx. So now that I have this, I can apply my integration to all of them, and then I find my answer. Okay. All right. So this is equal to, I know if I integrate this function 2s raised to the power 3, I'm going to get my 2x 3. Then I add 1 to it, and I divide by what? 3 plus 1. Then minus the s squared over I have over here to become s squared plus 1. Then over what? 2 plus 1. Then minus 4x. It has power of 1. I add another 1 to it, and I divide by 1 plus 1. Then plus what? 2 is a constant, so I add what? X to it. Then I apply the limits to from -2 to 2. Alright, so from here, what I get is what? I have 2x power 4 divided by 4 minus what? 2 cubed divided by 3 minus 4s squared divided by here becomes 2, then plus what? 2x. Still applying my limits from -2 to 2. Alright, so this is now equal to what? 2 on 4 will give me what? 1 over 2 x power 4 minus 1 over 3 s cubed. This will give me 2 go here, 2 times, so it will give me 2s squared plus what? 2x. Still applying my limits from what? -2 to 2. So what this means is we are going to substitute the value of 2 in place of x over here. So we have half 2 raised to the power 4 minus 1 over 3, 2 cubed minus 2 raised to the power 2 squared plus what? 2 raised to the power 2. Then minus, then I now substitute -2, so it will be half -2 raised to the power 4 minus 1 over 3 -2 cubed minus 2 into bracket -2 squared plus 2 into bracket what? -2. Alright, so if we solve everything that we have over here, we are going to get -8 on 3 plus 4, then minus everything at this side, we are going to get what? 8 on 3 minus 4. Alright, so if we simplify everything we have over here, we are going to get 8 on 3 as our final answer. So this is the answer we get if we integrate the function that we have over here, applying the limits to it. So thank you so much for watching. I hope this tutorial helps you understand how to integrate a function, and then how to integrate both an indefinite integral and then a definite integral. So thank you so much once again for watching, and I'll see you in the next video. Bye bye.